Well, hello there, distance learners. Here's your warm-up today. Reduce the following into simplified fractions. Do you remember how? Let's make those simplified improper fractions, please. And I think we can get this going. Go ahead, turn those into simplified improper fractions. And away we go. All right, everybody. Go ahead and let's get to it in 5, 4, 3, 2, 1. Behold the future. All right, so let's talk about how to do these, guys. Any three of them is just fine. Let's see if I can get a little bit of help, and I would love to get it from, looks like that's going to be, I don't know why I'm making all these arrows here. Maybe I need to do this. There we go. Which one would you like to help me with? And I'd like to get a little help from, let's see here. Let's go for, I'm just going to draw cards to life. There we go. Paul, which one would you like to help me out with? Sure, so 38/12. What did you get that for that as a reduced fraction? How many of us got 19/6 for that? How fantastic. Paul, can you tell me how you got that? Sure. So really what you did, whether you realize that that's what you did or not, you turned 38 into 19 times 2 divided by 6 times 2. And 2 divided by 2 is 1, and anything times 1 is itself. That's what happens when you're reducing a fraction like that. You're really saying, here's the factors of it, and common factors are going to divide out. So, for example, in 512, if you wrote down all of its factors on the numerator, all of its factors on the denominator, cross out everything they have in common, you would get the reduced fraction. And the same with number 3. So where this brings yes, ma'am? Oh, you mean a mixed number? Which is 3 and a 6, right? Yeah, very good, very good. So they're both reduced. This is the one I was a little more interested in, the improper fraction. That's okay, for reasons that are going to become obvious soon. Will you guys open up your planners to page 56? Happy Party with Your Stuffed Animals Day. Woo! Or as I like to call it, every day during quarantine. Yeah, absolutely. You set up your stuffed bears and you're like, morning, gentlemen, let's party. And you just kind of jump on your bed and they like sit there and kind of tumble off. And you're like, you guys are crazy. Hey, speaking of page 56, did you guys know if 8 people are on a sinking ship and the lifeboat only seats 5, there are 56 ways to leave 3 people behind? That means if table A, C, and D were on a sinking boat, there's 56 ways you could choose which 3 of you are going to die. Paul's like, dibs. Or, you know what, I could totally see Paul being like I'm standing there like, all right, guys, there's 56 ways to figure out who gets left behind. And then Paul just like jumps in and he's like, what are they? I just wanted to sit down is all. All right. What is our first essential question? And I hope that I can get that from, that's going to be Colin. What's our first essential question today? What are power expressions? Oh yeah, I'm supposed to be writing these down. What are power expressions? There's a second essential question, and I hope I can get that one from Ashley. What's our second essential question? Good. How can I simplify power expressions that have been multiplied or divided? Okay. Let's see here, everybody. So let's go ahead and get started. Let me grab my notes here. Hey. I don't remember locking that. All right, there we go. All right, underneath your warm-up, guys. Got a pencil? Today's topic is Power Expressions 1. Thank you. Multiply and divide. Okay. Let's get our voices off, guys. Let's make sure we're talking about that. You guys know what exponents mean, right? We've done a little bit of it with our equations, but the thing is that I've found, and this is true of all classes, and I find it's actually especially true of my GT classes sometimes, is that students get very good at doing a thing without really understanding what that thing is. So for example, if I asked you what 7 to the 6th is, if I asked you what 7 to the 6th is, you'll notice that lots of people are currently busting out their calculator. They're asking, what is 7 to the 6th? So let's see if I can, put in 7 to the 6th power. And you're like, hooray, I got 117,649. And that's great. 7 to the 6th is 117,649. But more importantly, what does 7 to the 6th mean? Teach! Well, that's just it. The answer to that, what it is less important than what I'm asking is what it means. 117,000 something, something, something. All right, everybody. Can I get you in 5, 4, 3, 2, 1? Let me see if I can get a little bit of help out there. What does that actually mean? Henry, what does 7 to the 6th power actually mean?
It means that you're multiplying 7 times 7 times 7 times 7 times 7 times 7.
I often say it's a string of 6 sevens multiplied together. You'll hear people say other things like it's 7 times itself 6 times. That's okay, but I worry about 7 times itself 6 times because that makes it sound like there's 7 of them. Because if it's 7 times 6, 7, that worries me. But again, as long as you understand it's a string of 6 sevens being multiplied together, that's what I'm looking for. And that's the same as true with variables. Like a to the 4th is just a string of 4 a's multiplied together. And also what people would say in college when they would meet me on a blind date. Ah. I like how some of you laughed and the rest of you were like, aw. I mean, I get it, but aw. All right. Folks, exponents are repeated multiplication, which is kind of funny. There's exponents are repeated multiplication, and multiplication's repeated addition. There's actually a denotion for repeated exponentiation. And you don't have to write it down, but especially because I'm not actually 100% sure if I'm correct or not, I believe it gets denoted like this. 5, 2, 3. And what that is 5 to the 3rd twice. Okay? The applications of that are ridiculous and actually involve quaternions, which are 4-dimensional numbers. Anyway, moving on. Because as long as you understand that exponents are repeated multiplication, you're in good shape. So let's go ahead and take the anatomy of a power expression. Let's go ahead and write this down. Anatomy of a power expression.
The answer to the thing you said 5 to the 3rd to the 2nd is 15,625.
It is a big number. There's no doubt about that. Like I said, the applications of it are actually kind of silly. Well, not silly, very interesting, but so far beyond our grasp that I'm not even going to take any more time to talk about. Anyway, a power expression looks like this. It's a number times some other number raised to some other number. A times b to the n. A times b to the n. Yeah, actually, I wish to color coordinate this. Hang on. I usually do. I don't know why I forgot. So the B, we're going to make you pink. And A, you're going to be
Green love. Oh yeah, it's the Joker.
grin. All right. Come on up in 5, 4, 3, 2, 1. Let's start with the one everybody knows. This n, the special name for this number, is the what? Just say it. That's the exponent. And it represents how many we multiply. Oops, that's multiply. Guys, B, does anyone know what the B is called? It's called the base. Hey, you guys beat me to it. That's the first time in the history of teaching this, guys, that I never got to make my joke when people are like, well, I'm like, what do you think we call that? And no one says anything. And I'm like, Megan Trainor knows what it is. Yay, because it's all about that base. About that base. About that base. That's what we multiply. Yeah, Megan Trainor knows what that's called. That's what we multiply. It's called the base. And now, guys, this A, I remember there was one year and I was like, so what, does anyone know what the A is called? And I'll tell you right now, Megan Trainor doesn't know what that's called. And someone was like, you don't know that. And I was like, that's true. I actually don't know if Megan Trainor perhaps remembers this from middle school math, what we call that thing. And the thing is, she might, but I can tell you she hasn't written a song about it. Or if she has, it is a song I haven't heard, but must listen to immediately.
Soprano.
Does anyone know what that thing is called? The A, yes.
The soprano.
No. Go ahead.
The tenor.
No.
I don't know.
No.
The alto.
Go ahead.
The secret multiply thingy.
That's what it is, but it's actually called a coefficient. I know you're a coefficient because you're by a base. Coefficient. Now, guys, this is really important. The coefficient is really just any value that multiplies with the power. And I want you to notice, if we use the order of operations, does the n talk to the A, the B, or to both of them? Does the n talk to A or B or both? It talks to just the B. The order of operations demands that you do exponents before multiplication, which means I would say that if n was 5, for example, this would be a single A times 5 B's. A times B times B times B times B times B. Now, hold on. I need you in 5, 4, 3, 2, 1. More on that in just a minute. In the meantime, guys, what would this be? Got a pencil? 4 to the 6th times 4 to the 3rd. I mean, you can put that in your calculator and tell me what it is, but I want you to actually tell me what that means and see if you can shorten it and not lengthen it. Talk to each other. What is that if I wanted to write that in a shorter way? Teach. Hooray. Oh, I see. Is that it's a pin. You're not going to go put that on my seat, are you? Oh, that's like a classic prank. That's never happened to me, but that's so close. It's so close. It's so close. Dane's problem is right around the corner. I don't think it's this week. It's next week. Or maybe not next week, because next week's weird. But it'll be the week after that, because next week's Thanksgiving break.
Next week is amazing because we literally only have like 2 days.
It's Monday, and then I think a distance learning Tuesday, but I'm not 100% sure. Okay, everybody, can I get you back in 5, 4, 3, 2, 1. So yeah, you can put this in your calculator, and you're like, oh, I know how to do that. 4 to the 6th times 4 to the 3rd. That is the biggest number. Whoa, that's not going to work. 4 to the 3rd. That is, yay, 262,144. And I was like, hey, no, I want that shorter. So, India, what did you get for that? Yeah, because if you think about it, it's 6 4s multiplied together. And then 3 4s multiplied with that, which is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 4s, 4 to the ninth. Now, how many people here can see a super shortcut so we don't have to write out that thing every time? Ooh, let's try this one. Got a pencil? A to the 7th times A squared. I want you to, if you need to write that out, you can, but I can rewrite that as A to a single power. And I want you guys to talk to each other about that. Talk to each other, and here we go. Teach. It is 10. Very good. You getting this down okay? Can I see? There you go. Go ahead. Oh, that's great, but I need it written down. That's part of my expectations in class. Okay. Can I get you in 5, 4, 3, 2, 1? Let's see here if I can get a little bit of help. Lars, how many A's are being multiplied together there? There are 10. There's 1, 2, 3, 4, 5, 6, 7 times A times a couple of A's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. Now, guys, in just a second, I'm going to give you one that I command you to not write out. The question is, what is the pattern here? What are we actually doing to make this easier for us? So, with that being said, got a pencil? Z to the 25th times Z to the 13th times Z to the 40th. Again, do not write this out. See if you can follow the pattern and see what that's going to be. Or perhaps Z what it's going to be. Ha, ha, ha. Give it a shot and teach. We're recording. We are recording. He's good.
Is he a cat?
He is a cat.
Does he sleep all day?
Usually. My daughter described my cat quite accurately as he's the kitty who eats everything. That's about right. Yeah.
I got the answer. So 4 to the 6th times 4 to the 3rd. I did this by hand. 262,100.
And that's awesome, but actually I think that's less interesting than 4 to the ninth, personally. To me, that's less interesting. All right, guys, I need you in 5, 4, 3, 2, 1. Shh. Henry, what did you get for that?
I got Z to the 78th power. That would be long to write out.
How many of us got Z to the 78th power? Henry, how did you get that without writing it out?
I just added all of the exponents together.
Oh, look at that. If I have 25 Z's, 13 Z's, 40 Z's, I get 78 Z's. If I have 6 4s and 3 4s, I get 9 4s. Wait a minute, that doesn't work, because look, there's 7 and 2, and that adds up to 9. But I got 10. I got 10. Ashley?
I got it right.
What's that? Yeah, so secretly, what exponent do you think belongs there? 1. Exactly so.
No, a zero exponent would just mean that the thing was zero.
We'll talk more about that in just I don't know if we'll get to that today, but we'll get to that today or tomorrow. So A to the 1 is, if there's nothing there, it's secretly a 1. And so when we multiply powers with the same base, we add their exponents, and this is exactly why. Because it's really just saying I've got 7 A's and then another A and then 2 A's. That's a grand total of 10 A's to make your life a whole lot easier. Now, folks, sometimes this requires just a little finesse. For example, got a pencil? T to the 3rd U squared V times T to the 8th U V to the 3rd. Go ahead. What do you guys think? That is a string of multiplication. How do you think we handle it? Teach. Remember, multiplication is commutative.
Wait, are the U and V together?
That's a great question. Look at your anatomy of a power. I'll tell you right now, the answer to that question is the most commonly missed thing I see on these ever. Well, no, second most common thing. That's good.
3 u to the second times
Okay, everybody, can I get you back up here in 5, 4, 3, 2, 1. Let me see if I can get a little bit of help out there. Oliver, what did you get for this? I'm so glad we're talking. Oh, great. Well, no, then you do have a clue. Do tell. I love it. We value all answers here, right or wrong. Tell me what you think. Uh-huh. And I would say almost. Almost. You've got all the right ideas, but you've actually made the second most common mistake I see when we're doing power rules. Real quick, how many of us got what Oliver got? T to the 11th, U to the 5th, V to the 4th. That's okay. Can anybody tell me, before you tell me the right answer, can anybody tell me what Oliver did incorrectly? Can anyone tell me what Oliver did incorrectly? Addie, please.
Well, basically, because anatomy is a power,
Uh-huh.
you have to multiply the exponent before you can. So basically, you have u v3.
Yes.
You need to multiply v to the third power before you can multiply u.
Right. So Oliver, the 3 is only talking to the v. Because since exponents come before multiplication, you would technically be doing v times v times v, and there's only one u there to multiply with it. So since there's only one u there, what could you change that to? So there's 2 here, and there's 1 here, because there's a secret 1, for a total of 3. How many of us got t to the 11th, u to the 3rd, v to the 4th for that? Perfect. Very good. All right, guys. I'm going to tell you that was the second most common mistake I see. Are you ready for the most? Here we go. Got a pencil? 7, a to the 5th, b, c to the 10th, times 3, a, b to the 12th, c squared. What is that? Teach!
What is that?
Indeed.
I think my brain just melted.
That's okay. It's like a butterfly. Did you know that caterpillars melt before they turn into a butterfly? Yeah, if you open a chrysalis, it's a bunch of goop. Doop 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 deep 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 doop 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 deep ba boop beep deep dap da doop. What do you think? What part's freaking you out? She circles the whole thing. She's like, this part, absolutely. So what makes this problem different than the one before?
I also was struggling.
Okay, so let's see. For this first one, how many t's do I have multiplied together there?
3?
And then are there any other t's I'm multiplying with that? How many?
Or you're adding 8?
Yeah, so since I've got 8 t's over here and 3 t's over there, technically I could scoot those over and just make it 3 t's and then 8 t's, which is a total of 11 of them. And that's why we're adding the exponents, okay? So what makes this different? Or actually, it's the part that aren't variables, I think. Try it without the coefficients to start. Just do it with the normal numbers and then see what you want to do with that coefficient. All righty, everybody. Can I get you back in 5, 4, 3, 2, 1? Shh. Let's forget the coefficients for a second, the 7 and the 3, because that's what makes this problem so different than the ones that we've dealt with before. And see if we can try to talk about this without first. So Xavier, without the 7 and the 3, just A, B, and C, I could rewrite this as something, A to the what, B to the what, C to the what.
So the something or the
I want the exponents first. Forget the something for now.
have a to the 6,
Yep.
b to the 13,
Yep.
and c to the 12th.
How many of us got something a to the 6th, b to the 13th, c to the 12th? That's correct. Now, folks, what goes in the blank? I'm going to tell you right now, I saw more wrong answers than I saw right answers. And one of them was 21. One of them was 10. One of those is right. One of those is wrong. I'll tell you, I saw the wrong answer more commonly than the right one. Talk to each other. Which one's right and why? Teach!
Well, I think it might be 21. I don't know.
I'm sticking with my answer. I think it's 10.
Okay. I saw table F jiggle with excitement because you guys got the right answer. When I was like, almost everybody get it wrong, I saw both of you guys go like, woo, like do a little dance. All right, everybody. Can I get you back in 5, 4, 3, 2, 1? All right, guys. I'm going to pull up my highlighter here. Let's get it nice and big. You guys can see my highlighter here, right? So when I'm hovering over the right thing, I want you to give it a polite little golf clap like this. And when I'm hovering over the wrong thing, I want you to mutter disapprovingly like, are you guys ready? That's true. Guys, the correct answer is indeed 21. A to the 6th, B to the 13th, C to the 12th. But wait a minute. Why on earth is it 21? Can someone explain why it's 21? Look at all these hands. Riley, I want to hear from you. I'm so sorry, guys. I can't hear Riley. Shh. It's all multiplication, right? The reason we add exponents is because technically this is 5 a's multiplied together times 1 a multiplied together. It's a weird thing to say. But that's 6 total a's being multiplied together, right? But multiplication is still what we're doing. And the last time I checked, 7 times 3 was 21. 7 times 3 was 21. Now, but 7 plus 3 is 10, but I'm not adding these numbers together. I'm multiplying them. It's just that when I multiply powers with the same base, I add their exponents. Because I'm taking a single b times 12 b's, and that's a total of multiplying 13 b's together. Cool. So, got a pencil? What is a to the 9th divided by a to the 7th, do you think? Teach! It is, Oliver. It is. Now, how did you get that? And can you justify it?
I know why. Because you have a times a times a times
Yes.
that, and it's divided by, and so you cross out the sevens because they
Very good.
match. You know what I mean?
I do.
You're left with only 2 a's.
Precisely. Okay, everybody. Can I get you back up here in 3, 2, 1? Shh. Oliver, you're absolutely right. What was it? Exactly. It's a to the 2nd power. How many of us got a to the 2nd power there? Perfect. Now, Oliver, how did you know that? What did you do?
So I guess it's like so division is the exponents are all multiplied.
Yeah.
The a's are all multiplied together.
Yes.
So when you divide, you're just taking away.
That's beautiful. Yeah.
Take away the 7 out of the 9, and then you do.
That's right. If I had 9 a's in the numerator and 7 a's in the denominator, why did I do this to myself? Then, just like we did in our warm-up, you start dividing things out until you run out, and you can see there are 2 a's left. So when you divide powers with the same base, you subtract the exponents. Got a pencil? G to the 14th, h to the 12th, divided by GH to the 5th. What do you think that is? Teach!
Why do you do this to us?
For the lulls. Yeah, right. We're learning lots of lulls stands for lots of learnings.
What's really funny is
Lots of learning actually from in my class. Alrighty then, can I get you guys back up here in 5, 4, 3, 2, 1. Jonas, what does that come out to be?
EH to the 21st.
How did you get that?
I went up to the top and I multiplied those together.
So you added the exponents to get 26.
So it was GH to the 26th divided by GH to the 5th, which is, I personally think this is 100% wrong.
It is. Well, I wouldn't say 100%, like 90%. But I do like where your head's at. The thing is, the only issue that you have here, Jonas, is that you actually combined the exponents. What is this square down here? I don't know what that means. The only thing that you did that you're not supposed to do is that you actually combined the exponents of two variables that don't have the same base. I can only do that when they have the same base. I can't do G and H because they're different numbers, right? So I am actually not allowed to add those together to get 21 or add these together and get 6. Not allowed. So instead, I want you to think about it like this, Jonas. How many G's are upstairs? How many are downstairs? A secret 1. Yeah, which means if I divide out one of those G's, how many are left over?
13.
So I get G to the 13th. Same story here. I got 12 H's in the numerator, 5 H's in the denominator. So how many H's are left? 7. G to the 13th, H to the 7th. Who here got G to the 13th, H to the 7th? Hooray! You guys are doing awesome, and I think you guys absolutely deserve a point with this. I think you guys are doing most excellent. Thank you, everybody.
Oh, yeah!
Well done. Okay, so I got 2 more things that we got to do before we leave. One of them's freaky, one of them's deaky. Do you want the one that's freaky, or do you want the one that's deaky? Freaky with an F? Freaky with the F. Okay, we're going to do the one that's freaky with an F. Here comes the freaky one. 16 x to the 9th, y to the 5th over 12x to the 5th, y squared. That's the freaky one. Do what you got to do, and hint, hint, I'd rather have a reduced fraction than a decimal. Teach. Indeed. Sorry, guys, they're getting big about the barriers here. Got to make sure we have one up betwixt. Thank you.
I get what you mean.
I love my job. All right, everybody. Can I get you in 5, 4, 3, 2, 1? I'm assuming just about everybody got the variable part just fine. That should be x to the 4th, y to the 3rd, yes? Now, I'll tell you right now, you know what does not go in here? 4. 4 does not go in there. Can you guys talk to each other? And by the way, hint, hint. Why is that not 4? Teach, teach. Okay, can I get you in 5, 4, 3, 2, 1? Shh. Matthew, why is that not 4? Shh. Because we're dividing, and we're doing the same thing. Those are not powers, right? That is 16 divided by 12, which means that we're actually going to reduce that fraction. Do you have that reduced for me, Matthew? 1.3 repeating, or if you reduce that by 4, 4/3. Now, folks, on Canvas, what this is going to look like, and we still have to do the Deaky example, so don't worry, we're going to do that. On Canvas, you'll see a problem like this, and it will say blank, x to the blank, y to the blank, and you just fill in those blanks. All right, we made it freaky, let's make it Deaky.
How would you write a decimal?
Oh, you're not going to. I want a reduced fraction. Got a pencil? Are you guys ready for this? I wish you could see the grin on my face. I'm wearing a mask, but you can't. Maybe you can see the evil in my eyes. Here goes. A to the 9th, B, C to the 3rd, all over A to the 5th, B to the 5th, C to the 3rd. Teach. What? I don't know. That's a lie. I do know, but I'm not going to say. Xavier sees where we're going. Lots of learnings. All right, guys, let's do it. Can I get you in 5, 4, 3, 2, 1? India, what did you get for this? I'm so excited.
Okay, for this I got a to the 4th, b to the -4th, and I forgot if you keep the 0 to the c to the 0, but I did.
Well, that's certainly what happens when you subtract their exponents like we've been doing. 9 minus 5 is 4, 1 minus 5 is -4, and 3 minus 3 and 0, to which I have one 3-word question. What the heck? What is this? What on earth is this? Negative exponents? 0 exponents? What is happening here? Xavier, you have an idea.
So, technically, can't you just convert it? Or because technically if it was -4,
Yes,
it'd be kind of weird.
I agree. That's a weird thing to say. B, it's -4 b's multiplied together. What?
You could do it so it's negative b to the 4th.
I'm afraid you can't. That's actually very different. Does anyone think they have any clue what b to the -4 actually means? Go ahead, Henry.
It's b times b times b times b times the negative.
It is not. It is not. India?
I think, and again, I have a super raw. I'm pretty sure it's b divided by b divided by b.
I think that's technically mathematically correct, but we're going to simplify it. Watch this, guys. Let's focus only on the bees. Whoops. Let's focus only on the bees, which is good advice if you're on a honey farm. It's b to the 1st, which is just 1 b, divided by b to the 5th, that's 5 b's. So, what happens to these b's? Well, you cross 1 out, and what's in the denominator? 4 b's. That is, b to the -4th equals 1 over b to the 4th. A negative exponent is actually saying this is in the denominator. So great. What is c to the 0 then? 0. It is most certainly not. Say it again. Is that Alec? Who said that? Alec said it. Alec, what is it? Because if you focus on the c's only, c times c times c divided by c times c times c, they all divide out. But remember, a number divided by itself is, which means technically this is a to the fourth over b to the fourth. But in Canvas, you're still going to write it by filling in the blanks 4, 4, negative 4, 0. There are 2 self-assessments, but guys, they go pretty quick. They're just like these. Do your best, come back with questions, and I'll be sure to make that happen. Tomorrow, we move on. That, by the way, guys, in Math 8, that was a week and a half. That was a week and a half in Math 8 that we just did. Does it feel like it? I thought it felt like it. That's the idea. Do you guys want to say goodbye to the distance learners? I know, lucky those guys. Those guys actually get to pause it. You know what I mean? Like pause it.